Good morning, everyone. I hope that you're all keeping well and keeping safe on this temperate Wednesday morning in Johannesburg. And thank you for joining us for the first webinar in our virtual event series, where I'll be taking you through an application of artificial intelligence in finance, namely that of bond rating classification with MATLAB. Some background about me. My name is Varushan Kupu, and I am a solutions engineer here at Optimum. I am also a biomedical and electrical engineer, but my role at Optimum as a solutions engineer is more geared towards supporting customers in solving their business-critical problems, underpinned by the successful adoption of the MathWorks tools. Some housekeeping notes for today. Please could you keep your microphones muted and video cameras off for the sake of bandwidth, and just a heads up, this webinar will be recorded. If you have any questions, please send them through to the chat and they'll be addressed in the Q&A session at the end. In terms of what we'll be covering today, I'm going to take you through our problem of what we'd like to address, namely that of bond rating classification, and after that there'll be a quick primer on what machine learning actually is. Thereafter, we'll go through a demonstration and then quite an important aspect of machine learning relating to its interpretability, which may be pertinent to many of you in the financial industry. Here's our problem. Given a portfolio of bonds or a set of bonds, how can we effectively and efficiently, given some sort of data about the bonds, classify them according to a rating scheme? Let's say that AAA is the best and CCC is the worst. That is our problem. Now, how can we go about solving that? If we look into our problem definition in a little bit more detail, we're going to be overlooking a portfolio of bonds, and we want to develop some sort of rating engine, but using machine learning. Specifically, we want to penalize misclassifications of non-investment grade bonds. So what do I mean by this? Well, we have 7 types of bonds, ranging from AAA to CCC. CCC, being the worst type of bond, is non-investment grade. So we want to try and avoid the situation where our model is given an investment grade bond, so AAA, to B, and actually classifies that as CCC. We're going to take a look at how we actually incorporate that concept into our model. Now, we're given various predictors about the data, and what's important to note is that this is synthetic data for the sake of this example in order to prove the concept, where each of the bonds have a different unique identifier, and there are 5 financial ratios associated with each bond. For instance, this one over here is working capital divided by total assets. Here we have the earnings before interest and taxes divided by total assets. And we've also got in this last column over here the industry to which the bond belongs. An arbitrary descriptor, say for instance, bond number 1 belongs to the insurance industry and bond number 2 belongs to the healthcare industry. All of these predictors are going to be input into a machine learning model where the goal is then to classify the bond, and this classification is going to be our response variable. In other words, what we're trying to model. Having a look at our workflow that we're going to look at today, we're going to start off by importing our data, and then we're going to prepare it for our model. These first 2 steps, data import and preparation, may seem trivial and quite banal, but they are actually very fundamental in machine learning workflows and very important. Thereafter, we're going to fit a basic model, and then we're going to improve on that model using a cost matrix. Okay? thereafter, we're going to evaluate the performance of our two models. Now, I'm going to go into the technical detail of what a cost matrix is a little later, but briefly for now, the basis of a machine learning model is there because it wants to try and optimize the misclassification error. It wants to try and get the most optimal classification error from your predictors to your response variable. The idea of a cost matrix is just there to ensure that certain misclassifications occur less. All right? And as I said, I'll be getting into that in a bit more detail later on. That being said, I've spoken about this mysterious thing called machine learning, and you might be wondering, what is it actually? Now, as apocalyptic and end of the world as 2020 has been, you might think that machine learning and artificial intelligence has something to do with robots coming for us and the end of days. However, I can assure you that this is far from the case, and machine learning is actually something far less sinister. It actually refers to the capability of a machine or a computer to match or exceed human behavior by training that machine or computer to learn the desired behavior. So we're going to be training a model in order to classify our bond ratings for us. All that being said, now that I've described our problem and our chosen approach to solving that problem, I'm going to go straight ahead and jump into our tool of choice, being MATLAB. Welcome to MATLAB, and you can see all of the typical components that we're used to. The current folder view showing all the files you currently see and have access to, your command window where you can interactively and quickly type in quick commands that will be able to run, and your workspace showing all the variables that you currently have access to. In addition, we're working with the live editor, and you might be familiar with .m files, and .m files are MATLAB code files where you can write code, but they're quite flat, and they're flat when you compare them to a live script, being a file with extension .mlx. And the live script is a type of way to write code in MATLAB such that you can intersperse code, comments, and the outputs of those code and comments within one linear, easy-to-read document, which is then very easily shareable in a variety of formats, including a PDF and Word document. Awesome. Let's begin with the demonstration. So as we said, our goal is to classify a bonds rating based off of various predictors. It is important that we do not classify any CCC bonds as being investment grade bonds. Let's jump straight into our first section, being that of importing data. Okay, I'm going to read in our data from a .dat file. You can think of a .dat file as being analogous to a text file or a CSV file, and I use the read table function in order to bring this data into MATLAB. Now, of course, you're able to read in data from a variety of sources: spreadsheets, databases. If you had a Bloomberg or FactSet license, you could even use a data feed type of framework to stream that data directly into MATLAB and work with it from there. Once we've imported our data, we now need to prepare it. The thing that we're mainly going to prepare is to convert our variables into categorical variables. What do I mean by this? You'll notice that when we imported our data, the industry, which I mentioned is an arbitrary description of a hypothetical industry to which a bond could belong, is given here, but they're given as numbers. The rating of the bond is also given but they have these quotation marks around them, which implies that MATLAB is reading them as character arrays. Essentially, you can think of them as MATLAB is reading them in as words. However, this isn't going to be useful for us in order to build a model. In order to allow MATLAB to think of these variables as discrete units, we use the categorical function in order to convert the industry into a discretized unit which MATLAB can then build into the model. And if we plot a histogram, we can see that there's a fairly uniform distribution of industries across the dataset. While we're going to perform the exact same thing for the rating, it's important to note that the rating that we deal with over here has an ordinality associated with it. So you actually want to tell MATLAB that AAA is better than AA, which is better than A, where CCC is the least ranked variable. Our industries had no ordinality. They were all equally important. However, our bond ratings do. And here's the distribution of our ratings across the data set. Cool. The next part of our data preparation is to set aside some data for training and testing. Now, in a machine learning workflow, you're going to need a substantial chunk of data, ideally as much as you can, in order to allow the model to learn the features of that data. This is referred to typically as a training set. We're going to call it bond data, all right? And once you have set aside some data for training, the remainder of that data is going to be used for testing. So that acts as unseen data that we apply the model to, and then we see how well it can evaluate and test itself along with brand new out-of-sample data. And we're using 20% of our data for testing. Now that we're done with setting aside data for training and testing, we're going to fit our classification model. And of course, since MATLAB is an integrated programming environment, you can of course write this in code from the beginning. However, I'm going to show you a more interactive workflow of doing this, and this is going to be done using what's known as the Classification Learner app. In order to access the Classification Learner app, you can run the following command or go to the Apps tab and select Classification Learner. I've got it opened, so let's begin. The main benefit of using an app like the Classification Learner is that it allows you to follow a workflow interactively without programming it from scratch, and to try a variety of models and algorithms in order to see what fits best and what works best for your model. There are a variety of MATLAB apps ranging from applications to image processing, curve fitting, and machine learning. Let's begin by importing our data. We're going to select bond data, as this is where our training data is stored, and we need to specify the response variable. I'm going to select the rating to be our response variable, in other words, the bond rating, and now we can select and deselect which predictors we feel are relevant. I'm going to deselect the ID, as that's not a particularly relevant variable for model building in this case. We can then choose a validation scheme. I'm going to go for 25% holdout validation, and in essence, validation is used to prevent a model which is overfitted. Now, an overfitted model is one which will perform very well during training, but it doesn't generalize well to new data. And validation is a method with which we try to prevent overfitting. Let's start the session, and what you see in front of you is going to be a range of models which are now available. Up here, we get various types of machine learning models, from decision trees to discriminant analysis, logistic regression, etc. These are all the models which we are available or have available to train our model on. Some of them are grayed out because our data is not of the right type, and that's probably because these models want numeric data only, and we have some categorical. Note that you can also train an optimizable model, and that's a model which optimizes for hyperparameters. All right? I'm going to select all models. So let's actually train all of these models and see which one's the best, or have a look at the corresponding accuracy. I'm going to be using the parallel pool on my computer to train the models in parallel, and while the models train, where the parallelization helps the models to train a bit faster, let's have a look at what these plots look like. So this is a scatter plot where you can either view it as according to the predictions made by the model or your raw data. So let's just click on raw data for now, and you can actually see the relationships between various predictors and the classes that they fall into. So it's a nice intuitive way of visualizing what your data looks like. Now, these are all the models they finished training on the left-hand side, and we see that the most accurate model was a fine classification tree. All right? Now, it had a 75% accuracy, and within the app, there are various ways to validate that accuracy. One of them is the using of a confusion matrix, and I'm going to go into the technical detail of how to read a confusion matrix shortly, and the other method is the receiver operator characteristic curve. Okay? Now, this has been a great exercise in terms of exploring the accuracy of various models. And you'll notice if you click on a different model, then the plots will update, and you'll get a sense of you'll get a sense of how your classification is performing. Now, this has been a useful exercise, but it would be more useful if we could actually implement this without having to go through this entire process. What MATLAB allows you to do is it allows you to pick a model and then actually export it in the form of either a variable, or you can export a function which will identically replicate everything you did in the app in order to arrive at this final model. I'm going to choose a medium classification tree for reasons I'll get into shortly. And when I click on generate function, this creates a MATLAB script where if I input the training data, it gives me out a trained classifier as well as a validation accuracy. And the extremely cool benefit of doing this is that it shows you quite explicitly how this was coded so you can learn yourself, and it allows you to edit it should you wish to change something later on. Automatically generating code is a real benefit of using MATLAB apps, and it can really help you to be more productive very quickly. This function over here that I've exported from the app is what I have saved as trained optimized tree, and that's going to create our machine learning model. Now, let's have a look at the classification tree, and this is why I chose a tree specifically. Now, when it comes to things like model explainability and interpretability, a classification tree is a good example of this, because in order, say, to get the decision double B, you can actually see the path with which the data traverses the tree in order to reach that decision. We note that at this first node, the tree reads from top to bottom. This ratio had to be less than 1.5 in order to go into this branch. Then that ratio had to be greater than or equal to 0.76 to go to that branch. And similarly until we get to our double B. Okay? This is one way that we can expose the inner workings of a machine learning model for greater interpretability. Okay. Now we're actually going to test our prediction. So what does that mean? We're going to take our model, and we're going to send in our training data in order to form a prediction. So what this means is that the model has taken, you can see that our training set, or our testing set rather, has 700 bonds in it, and the first two predictions were triple B, and then the next two predictions were triple A. Let's summarize this information using the confusion matrix. And the way to read the confusion matrix is that you've got the true class, in other words, what is the real rating of the bonds, alongside the predicted class of the bonds on the horizontal axis. In other words, what did the model predict the bonds to be? And the way to read this is that 119 AAA bonds were correctly classified as AAA. 36 BB bonds were incorrectly classified as BBB. All right? And it seems quite clear that the goal with the confusion matrix is to try and get as many classifications as possible on this main diagonal, or as close as possible to it. However, in our application, we want to try and avoid any misclassification of a CCC as any investment grade bond. All right? So the idea here is that we had 26% misclassifications of CCC bonds. How are we going to try and minimize this misclassification? We can introduce something known as a cost matrix. And this is how we're going to do this. Now, it's important to note that the words cost matrix here don't translate to a tangible monetary value or a business cost. It's more indicative of a gauge that we're trying to use to bias the model. All right? So this is what the cost matrix looks like. And you can see here that most of the numbers in this matrix are fairly small, except for in the last row, our CCC row, where the numbers are very large. And essentially, what this is telling our machine learning model is, hey, if you misclassify, or rather, if you classify anything in any of these spaces where the numbers are large, this is very bad. Okay? So try and train yourself such that you do not classify things or bonds into these ratings where the numbers are quite high. And this is how we try and bias the classifications. That being said, we then implement our classification cost matrix as a standard matrix in MATLAB. And now the question is, well, how are we going to incorporate it into our model? Well, first of all, before we do that, we actually need to try and figure out how much is our initial model, this one up here that I showed you, how much is that costing us in order to establish a baseline? And once again, it's not a monetary cost, it's more of an indicative cost. So in order to do that, we're going to take the confusion matrix I showed you earlier, and we're going to multiply it by the cost matrix. And when we sum all of these numbers, we see the cost that our model has incurred, and it's nearly 13,000. Once again, this is not an actual monetary value, but it's more indicative. Now, in order to implement this cost matrix, let's go back into the Classification Learner app. We can click a button that says Misclassification Costs, and then after that, we're given the option to import our classification cost matrix into the app. We can say import from workspace, and then cost variable is classification costs. We import it, and here's our matrix. We click OK, And now we can retrain our models. And that's exactly what I've done. I've retrained the model, I regenerated a function, and this is the function over here, train tree with cost, where now I'm sending in the bond data and the cost matrix as inputs. This creates or gives us another model with a second prediction. So in this model, the first prediction of the bond rating was double B, and then triple B, and then triple A again. All right? If we look at our cost matrix the classification matrix of the second model, the aim here is not necessarily to improve the accuracy of our entire model, but to bias the accuracy in places we desire important. And in this case, we can see that there are certainly fewer misclassifications of investment grade bonds as CCC bonds. The 26% odd misclassification has decreased substantially to about 10%. So this is by no means a final model, but it's definitely a step in the right direction for how you can begin to improve your model. And if we have a look at the cost of this optimized model, where we have our classification costs included, again by multiplying the new confusion matrix by our cost matrix, we see that the cost is substantially reduced and our theoretical savings are about 5,200. This is great news and it's quite encouraging to see. That brings us to the end of the demonstration. Let's get back to the presentation. Interpretability is important because models which are unexplainable are risky. And it's important for models to be transparent both from the perspective of business practitioners but also regulatory bodies. Score or rule-based models, while simple and explainable, have rather poor predictive power. On the other end of the spectrum, deep neural networks have very strong predictive power. However, they're kind of a black box. They're difficult to interrogate for many reasons. However, despite this, in MATLAB, there are various ways and methods for you to interrogate machine learning models that you see here in this diagram. There are ways to look at the sum-split criterion gains for the decision tree, like we just looked at. You've got ICE or PD plots, and also the Lime statistic, which is new in MATLAB release 2020b. For more information, you can click on this link in the presentation, which is going to take you to an article I wrote about this topic. In this presentation, we had a look at the problem of trying to classify the rating of a bond given financial information about it. We implemented this using machine learning techniques, and then we solved it all within the MATLAB environment. And we saw how quick and easy it was to develop a model and then improve on it. Folks, that brings us to the end of today's webinar, and I hope that you enjoyed it. Please feel free to watch the other webinars in our virtual event series. I encourage you to do so. And please complete the survey that you receive at the end of today's webinar. It will be posted in this chat. Once you complete the survey, you'll instantly get access to the presentation and code. I'll be turning off the recording now. Let's go through the questions.